हेलो एवरीवन। आज हम प्रॉब्लम सॉल्व करने जा रहे हैं। प्रॉब्लम लीड कोड प्रॉब्लम ऑफ द डे 746 मिनिमम कॉस्ट क्लिंबिंग स्टेयर्स। द प्रॉब्लम स्टेटमेंट इज गिवन इज you are given an integer array cost where cost I is the cost of ith step on the staircase. Once you pay the cost, you can either claim one or two steps. You can either start from the step with the index 0 or the next step with index 1. Return the minimum cost to reach the top of the floor. So let's try to understand the problem onto the one note. So let's say we have given an array like 10, 15, and 20. This the value is represented at the cost of this. If we are reaching this position, so we have to pay become we have to pay this amount. So we have to then after paying this amount, we can go to the next step or the next of next step. Okay, so what we can do, let's say first we will start with this position. So we can 10, we have some options 10 plus 15, we will go to the one by one, and plus 20, all three we reach. So other chances is we will directly go to the jump by skipping one step. So 10 plus 20. We have other options like we will go not go with this, we will start with this 15 because we can start from 0 or 1. So 15 and then plus 20, or we can directly we can skip one point, so we will reach end of the array, so 15. So we have to return the minimum from all of these. So the minimum from all of this is 15. Okay, so the problem statement uh, says that for this, let's say in this there is one switch case. One, we started with this position and skip one position with this element, reach this position, and then again skip one and reach this position. Again skip this, reach this position. Then skip, we haven't skipped this, and we continue with the next step, and we reached, and then we skip one and reach this position. So the number of 6, 1 plus 1 up to 6 plus, and becomes 6. So we have to find the minimum cost we can reach end of the array. So there is, we are able to think of like there are every step we have two choices. Chosen, चूज किया नहीं चूज किया. Okay, sorry to the disturbance. Every step we have two choices. Let's every step we have two choices for. So the one problem can be like this: the recursive to the power n problem. Okay, so think about it, and so the recurrence relation will be becomes, first we will pay for this and go for the next step. Else what we can do, pay for this and skip this step. Okay, there are, this is the test, the translation. Let's understand the code. I have written brute force approach for this. Vector started with cost and index. Int cost becomes size, and if index is reached to the end of the array, so we will simply return the 0. And one test case is chosen and not chosen for first element. Second is second element. We directly move to the next of next element, solving for the next sub problem. So we will returning the minimum of both the chosen and. So it is working fine, but the problem is this: it becomes, it comes into the clearly. So let's try to run, try run. happened? What happened? Okay. There is an what happened? Oh, I have changed the name as well. So for do let's see the code. Yes, this is the same. So now it should be done. Right? What happened? Oh, we have to remove this as well. Okay, okay, okay. No worry. So let's run this code. It should be very fine. Yeah, yeah, it's run successfully and gives the correct result. Let's submit it. This will give the TLE for the because its time complexity is to the power n logarithmic. So yes, we get the TLE for the 259 test case. So what we can do, we can use. Let's try to understand. There are some problems which we are computing multiple times. Means there are some problems. So what we can do, we can store them. If you have seen the DP problem, so we will store each of the result in a DP. Then we will go ahead with the next. So for that, in the second solution, we store the DP cost into a DP, then we are simply working on this. So let's run this program and DP solution. Uh, it will run correctly for all the test cases, and yeah, yeah, it's accepted. Okay, and now what we can do? So this is the DP. Let's summarize all these things with the time complexity. So the brute force time complexity is 2 to the power n, big of n, big of 2 to the power n. And when we use dp for dp, it becomes constant time. Constant, not constant, big of n. Okay, and the next, and the space complexity becomes big of n. Okay, big of n. And next step is solving without it can be optimized more. So let's think about. Yeah, we can do with tabulation method. If you have seen tabulation method, so let's try to understand the code. In this, what we are doing, rather than using any extra space as a DP, we are just taking the minimum of the positive element and storing into the same cost solve DP tabulation. And let's try to run this code as well. Yeah, it's working fine, and yeah, it's accepted. That's all for today. Thank you. You will get the solution PDF solution on GitHub.